This is Math 3, problem 2-6, and we are being asked to solve the following equations using a method other than the quadratic formula. So that means that we can either factor or we can use completing the square. So let's take a look at what happens. These are all extremely similar problems when you really get down to it. So we're going to do, I believe, let's do problem A and problem C and see what happens. So if we have y squared minus 6y equals 0, this is part A. And I like that there's a 0 here already because we know that when we have a quadratic with a y squared or an x squared in it, we must work on getting the 0. That's the way that we solve it. So I notice that I only have two terms, and then I do have a common factor in each term. So I'm going to factor out that y value, and that is like the reverse distributive property. So I end up with y squared divided by y is just y, and y divided by y is 1, so it just becomes minus 6 equals 0. And now this is just a zero product property problem. I can actually just draw the line because I have two factors. If the factor y is 0, then I will have a true equation, a true statement. And if y minus 6 equals 0, then I also will have a true statement because of the zero product property. So if I just add 6 to both sides, y could possibly be 6. Okay, so those are my two solutions for part A. For part B, it starts out a little bit more complicated, but we know we have to have a 0, kind of like we did here in part A. We've got to have a 0 on one side in order to be able to solve quadratics that have that squared, so this squared right here. So let's go ahead and subtract 3 from both sides, and funny enough, we're going to end up seeing that term cancel itself out. 19 minus 14t, and 3 minus 3 is 0, so we just end up with an equal 0. Now that we have only two terms, I can look for the greatest common factor. And if I look at this factor and this factor, I notice I have a t in both places, and I also have 2. So I'm going to divide by 2t, reverse distributive property, and I'm going to bring that little fella out, so I get 2t, and then figure out what's left. 2t squared divided by 2t, that just leaves me a single t left over. 14t divided by 2t, that just leaves me with 7 left over, and then the sign stays in at minus 7 there. And that still equals 0, which is exactly what we want in order to be able to solve these. We now have a zero product property. We have a factor problem. We can draw a line, and we can say, well, if 2t equals 0, I'm going to have a true statement because this times this will be 0. So I just divide by 2, and 0 divided by 2 is 0. Okay, over here also, and I know that you could probably mental math this, but just for demonstration purposes, we're going to show that we're adding 7 to both sides, and that t equals 7. Okay, so those are our two solutions for, oh, sorry, that's part C, my mistake. Okay, should we do this last one? Maybe we'll do that last one. Hang tight. All right, so we have 1/3 x squared plus 3x minus 4 equals -4. Notice we don't have a 0 all by itself, so I'm going to go ahead and add that 4 to both sides in order to get the 0 on the other side. And I'm left with 1/3 x squared plus 3x, -4 plus 4. Oh, how convenient is that? Those cancel. That equals 0. Alrighty, so now 1/3 and 3, not a common factor in there, but I do have an x and an x. So I can take out the greatest common factor of x and use that reverse distributive property, and we get x times, and x squared divided by x just leaves me a 1/3 x right here. 3x divided by x just leaves me with a 3 here, and that equals 0. All right, which is what we want. We want that 0 over here whenever we have the zero product property. So I'm going to draw my line. I can have x equals 0 here. That's super easy. But then this little factor has to equal 0. And let's figure out how to do that. If 1/3 x plus 3 equals 0, if I subtract 3 from both sides, this is why I got to have those little equation skills. 1/3 x, those cancel, equals -3. Now I'm going to use the multiplicative inverse property. I'm going to multiply by 3 over 1 on both sides, times 3 over 1. And those cancel diagonally, and I'm just left with the x. And -3 times 3 is -9. There we go. All right, so this is problem 2-6. I know this was a little bit of a long one, but I think it's very helpful.